All right, everybody. Here we are for week 18 of Foundations, and we are in Unit 12, Part 2, which is a continuation of our discussion of embedded programming and how to code on Arduino. So we've got a whole bunch of things that we've looked at so far that we've considered, and we're going to keep on exploring these ideas as we move through this week. We're going to do a little bit of a whirlwind review, answer any questions that you've got, and then we have 5 more essential concepts for Arduino and programming in general that we're going to cover this week. Also, it's worth mentioning that these ideas are definitely more advanced, and so if you're still working on trying to understand the first round of things, that is a good space to live for a while. You're going to be able to do a lot in there. We're going to also look at some, it's sort of an impromptu addition, but we're going to look at some alternatives to how you can code and other ways that you can build in code related things to your projects. But there's a ton of options, and we'll see how all these fit in. I do want to remind you, if you're a little frustrated with how this works, we're just doing the basics, and there's going to be parts that you won't understand by the time we're done with these 2 weeks. It is an entire career field, coding and computer science. So there's lots and lots of depth to this area. And I do not understand it all by any stretch. And in 2 weeks, there's no way that we're going to get close. But what it is a chance to sort of get your hands dirty, get in there, start coding things, like knowing where to even put the code inside of the computer so that it does some stuff, or inside the Arduino, and then starting to play around with it from there. So what we're going to be working on is getting ourselves put through this so that we can talk about all these big concepts. And so essentially there's lots of things. You get better as you go. For me, a lot of the time when I look at my months old code files, I am just happy if they're readable and logical. And for any of you who popped in a little bit early, that's what I was up to. Was playing around with an old code file, trying to get this to work for our plants watering system inside of MakeHaven. And I'm going to say it's not perfect at all. It doesn't work. So that makes it pretty straightly not working. I was trying to do fancy things up here with arrays of objects that I don't even know if C++ will let me do. But within the game down here, we're trying to get our plants to have a monitoring watering system. So that's really what this is all about. But there's lots of different concepts that you get into when you're starting to think about how you want to code stuff. And these are going to be some of the big heavy hitters. So these are what we did last week, was sort of the nuts and bolts of how you make it work. We talked about if then logic or if else logic. We talked about some math on an Arduino, while loops, for loops, arrays, those sorts of things. This week, we're going to go into higher level things. So we went through math and variables, arrays. There's probably moments, if you were working through those assignments, where you felt really, really smart, and other moments where you felt really, really frustrated. That is completely and totally normal. There is not anybody who jumps in and automatically gets the sense of this. It's definitely something that it takes practice and time to figure out. But basically what we learned last week, if you were to try and put this into language, if you're thinking about it as a language, what we learned were sort of the words and a little bit of the punctuation, maybe like how you would structure a sentence. But what we're doing now, what we're going to talk about this week, is more about like the paragraphs and how do you build a narrative? What's the structure of it going to look like? What are the things that you're going to talk about, and how do you fit those pieces together is going to be the key idea for this week. And so this is going to get you into the deeper levels of writing code so that you're thinking about more high level parts of this. While we're on our way, though, I do want to point out, here's a few of my favorite settings for the Arduino IDE, in case you're still a little mystified about what it is. I'm a big fan, and this you can get to by, I think I have Arduino open, or I can open it up in just a second. These are all inside of preferences on Arduino. And so let me pull up Arduino over here. We'll open this up, and let's just go to an example, file examples, basics, Blink. It's my favorite. And in here, we can go to preferences. And I know that it's probably a little small on my screen, but this is where you get to it. So you go to file, example, or file, and then down from there, there's preferences, or control comma. If you're way into hotkeys, control comma will get you there. on the Windows version of the Arduino IDE. And I'm a big fan of just a few of these settings. Display line numbers, I think really helps, especially if you're talking about your code with anybody. You can say, oh, I see you're missing a comma on line 17. And it becomes much easier to talk about your code with each other without like, it's in this line or a couple lines here. You can be more specific, so that's really helpful. I'm also a big fan of the verbose compilation. This is probably it's like an avalanche of information, which is too much. But if you're ever trying to scroll through and make more sense of what's happening, this can be really helpful. You could turn that on for compilation or for upload if you're trying to do either of those. And so there's some interesting details that come out with there. It's just fun to look at and watch it all scroll by, really. And then another big one for someone who's writing a lot of code is to enable code folding. And that's where your code can be sort of hidden away, where you can say like, this function's good, I don't need to worry about it anymore. And then you click a little button and it all folds away. So in the example here, if I zoom in a little bit and look at this code, here's code folding. I can say that my void loop starts on line 32, ends on 37. So that's my line numbers. But if I use this little plus button here, it folds up that function and makes it go away so that it doesn't take up any space on my screen. It can make it so that everything looks a little nicer. And I can say, oh, there's my void setup. And I don't need to worry about what's inside. It's all folded away. No problem. Code folding is a nice trick if you're trying to make everything look a little nicer. So those are just some fun strategies to employ. But the big things that we're going to talk about are this list: functions in code, variable scope, readability and maintainability, object-oriented programming, and libraries. These are our big idea concepts for the week. So first of those are functions. And functions are absolutely everything in Arduino. Maybe not technically, officially everything, but very close to everything. Even if you don't know that at the beginning, they're really the driving force of Arduino, is that functions are how you describe just about all of the stuff that you do. For example, setup and loop, those are totally functions. So void setup and void loop, those are the two things that you have to have in an Arduino program, the bare minimums, and those are both functions. So void and setup, the void just means that the setup function doesn't return anything. And for loop, that function is also void. It doesn't return anything. And it's a little weird to think about what returns until we look at an example that's sort of a practical function, which is add. And so in the case of this function add, you pass in two things, two numbers labeled A and B here, and then it spits back to you the sum of those. And this is a variable, this is a function with a type of int. So it will return an integer for you. So when I use add up here, so add AB, I'm adding two numbers, passing in those two numbers that I want to add, and it returns their sum. And so basically this code over here in the blue works exactly like this little red circle of just a plus. And I get it's a little silly to write a function like that, but we'll see that it can really isolate problems and make sure that it works nicely. One nice benefit is that, especially in a small example like this, there's no memory cost benefit that you're really worried about here. From time to time, there could be, but in this case, they're not. And so for a lot of this, it's really helping you isolate different pieces and parts of your program so that they can be more reasonable. And so setup and loop are functions, but you can add in your own custom functions to make things a little bit more sensible. And so here's two examples. Up here on the top, this is basically the exact thing that was on the last slide. If you're adding two numbers, 3 and 5, you could add them in a function. And this is maybe not that helpful that it just says add 3 and 5. Functions can be defined however you want. If you wanted to do this, it might make more sense to you. It might be reasonable, but it also may not seem that necessary. I mean, this is actually more characters written than just adding, right? And so it's pretty clear what you're up to in either case. You add or you hit add and add these two numbers together. Whatever the case may be, that seems fine. But then as soon as you start to enter any sort of complexity into your functions, the power of your code and the ability to write custom functions becomes a little bit more obvious. Here's the Pythagorean theorem. Everybody loves it. It's from math. Maybe you love to hate it. But you know, the three sides of a right triangle, you can calculate out a squared plus b squared equals c squared. It's a fun little math trick that you can use for triangles. And the equation for it is this: the square root of 3 squared plus 4 squared would be the answer for the Pythagorean theorem. And that's kind of a lot to look at. You know, the parentheses inside of parentheses, there's a lot happening there. And so it might be easier to read by defining your own function so that you isolate that all down here in lines 12 through 14, right? The Pythagorean, you take two inputs and then it does all this power stuff and the square root business. And you like had to think about that once, but you can put it away in a box so that you don't have to think about it again. And then when you're going through your program up here in lines 3, 4, and 5, you open your connection to the serial port and you say the answer to my Pythagorean function is going to be just whatever this spits back out. So I put in a 3, put in a 4, and it does all of the math for you and returns the answer to this would be 5, and then it prints that out. What this really can be useful for is when you can use a function to isolate away complexity. And it's helpful when you have to do it once like this, but it's really, really helpful if for some reason you're doing the Pythagorean theorem 100 times, right? Then you can call this function and it's going to behave in a reliable, repeatable way. And you don't have to write in this nonsense a bunch of times. You can just call this function that you've created for yourself and make everything a little bit simpler. So those sorts of systems can be nice additions if you add in your own custom functions to any code that you're writing. And it's really an essential part of how any good developer is going to write their code, is they're going to have functions that do the things that they want them to. Arduino recommends for sure that you declare functions. You can sort of get around without doing it for a long time, which is totally a beginner move that's completely reasonable, actually. But the faster you can learn how to use it, the more your code is going to start to get organized. And so Arduino really, this is from Arduino directly, these pieces of advice. They say that functions help the programmer stay organized, that one action can live in one place so that if you need to do something repeatedly, you can have it described in just one spot. It reduces the chances for errors across your code. The sketch can be smaller. It can be less actual code a lot of the time. And it's really easy to reuse code sections if you have them defined in functions, because you can just call a function and use it whenever you need to. So there's a lot of this that can be done that can make your life a little bit better if you declare functions and use that for your process of how you understand things. And so that's our first concept. Variables are useful, and functions are a key part of how we move around that information. So in here, the big nuts and bolts of a function is that you need to have your inputs, your parameters to a function. And so for this add function, which is going to be very easy for us to look at, the parameters of the function are two things. They come in order. And so whatever comes first is A, whatever comes second is B. And so in this case, 3 is going to be my A value, and 5 is going to be my B value. Inside of the function, these variables A and B, they just exist inside the function when they're created like this. And so this is going to be specifically 3 plus 5, not 5 plus 3, 3 plus 5. And so this system works really well for defining and describing functions, but then it raises some interesting questions like A and B are used here, but could I use those names anywhere else? Or what's going on? A big sneaky part of writing code, and this is something that I think evaded me for longer than I care to admit, is the idea of variable scope, which is there's something about a variable. So if you define a variable in your code like A or B, like we just talked about, there's a place where it lives. And so this is implied in every single variable in the Arduino framework, but it's really helpful to know how this works so that you can use it to your advantage. And so it's really important to think about how variable scope works. Like this is an Arduino sketch over here on the right. And again, serial is just taking information and sending it from the Arduino to your computer. So when you do this serial begin, you're starting a connection to your computer so that it can talk back to you. And in this case, we've got 3 variables. The first one is called Pat. Pat is the name of the variable. These are all very human names. So Pat is the name of the variable, and its number is 6. Sunny is another name of a variable in our case, and its number is 8. And Nico is the third name in this list, the third variable name, and its value is 11. And so in this program, we have Pat, Sunny, and Nico. Pat is defined here, Sunny is defined in the setup, and Nico is defined inside the loop. And in the setup, we do this serial begin. We start our serial connection, which is a little tricky that it happens here in setup, but it just needs to happen once at the beginning. And then serial print line is when you print out things to the serial monitor. And so for serial print line over the serial connection, we're going to print out whatever the value of Pat is, or whatever the value of Sunny is, or whatever the value of Nico is. That's what we're asking this program to do, is just to print out those three numbers. And this would be a repeating list of three numbers that's going to come out again and again and again and again. However, this code is going to throw an error. And so I'm going to stop talking for just a second and invite you to take a look and see if you can pick for yourself. Just think inside your head, which one of these three is going to throw the error? Which one will the loop not be able to print? Okay, it's Sunny. Sunny is the one that throws the error. And that is for an interesting set of reasons. This gets at the heart of variable scope. The easiest one of these to start to make sense of is what's going on here. Inside the loop, this is where we're asking it to print things. And so inside the loop is where we define Nico. So there's no problem printing Nico. This is the Arduino is going to be able to take this value and say, okay, print Nico. I know where Nico is. We just defined it. It's inside this loop. And so we can describe that and it'll serial print out 11, no problem. Also, and that's Nico lives inside this sort of purplish box in the code here. Nico starts inside the loop and ends inside the loop, and you can't access Nico outside of that purpley area. Pat, however, is up here and is a global variable. That's the category that we put those in. Pat's a global variable. Pat is number 6, his number 6. And so Pat could be accessed anywhere that's inside of this pink area, and that includes the green and the purple area. So Pat can be described and called in any of these places, can be modified in any of those places, can be used in any of those places. Having a global variable has a lot of appeal because it's so accessible. You can get to it anywhere. And in this case, Sunny is our troublemaker. Sunny is the name of a variable that is limited just to the setup. So sort of like Nico, it has a limited range. Variables are limited to the function in which they're described. And so Sunny, or where they're defined. And so Sunny is defined up here in the void setup. And so it's defined and assigned a value inside of the setup. And it can only be accessed inside the setup. And so once you get past the setup, and this only happens once at the beginning of an Arduino powering up, once you're done with that setup, the Sunny variable is actually garbage collected. It's gone. It's totally out, and the Arduino is done thinking about Sunny. So when you come back here and you get to this line and you say serial print Sunny, it's outside of Sunny's scope. Sunny has been he's been disremembered, forgotten. That's what I was thinking about. Sunny has been forgotten by the time you get down here. And so this is going to throw an error because you can't access this variable. Now we're trying to think about variable scope for the place where a variable lives. And that is definitely a tricky topic. Pat has some appeal because you can access that variable everywhere, right? That is, whether it's setup or loop, whatever, you can get access to Pat, and that's really helpful in a lot of cases. And a lot of beginners make lots and lots of global variables for that reason. But as a general piece of advice, you want to think about, do you need to make something a global? Making something a global variable like Pat is helpful, but it also means that you could accidentally impact Pat anytime that you do an operation. It also means that I can't use the name Pat anywhere else in my program, or else it might overwrite that value or do weird things. And so, or throw an error when you go to compile. Using the name Pat is then sort of off limits. So if you have something that's like a nice, repeatable, you want to use it a bunch of places name because it makes sense, then you're sort of cut off from that once you start to add in lots and lots of global variables. And for somebody who's writing little programs and there's some sensible things to have for names, that can be really important to be able to reuse your names. If the scope doesn't conflict, you can use those names again. So I could use Sunny here. I could actually use Sunny again in void loop and I'd have no conflict. Because their scopes don't overlap, I don't have any issue with using the same name in multiple places. And so that can be really helpful depending on what you're up to. And if you're writing lots and lots of functions inside of your code. There's also this other topic that we're going to pretend doesn't exist. There's pointers that are much closer to how memory and the hardware of memory works. And there you can like assign values and labels to different memory locations, and it's really cool. However, it's definitely higher level than even scope, so we're just gonna cruise on by it for right now. But if you want to, there's a link here, and you can totally go look at pointer access operators in Arduino reference. So we've got that. We've got a couple of things, functions and variable scope that we've talked about. And another thing that's really important is well-written code keeps readability a constant focus. And some languages are really good at keeping readability a primary thing. Python is usually touted as one of the great examples of a coding language that just looks like natural language, that just looks like words that you might read on a page in a book, where there's some reasonableness to how it's written. C, Arduino C is a little bit dicey on there, but it totally does work. And so within that, you can make choices that help your code become more or less readable. And this is definitely like a style points kind of thing, not a necessary thing. Your code can work without being very readable. In fact, it's kind of fun to build the least readable sketch you can, but having a more readable sketch can be really helpful. Like over here, this is the way that they used to have the example sketch for Arduino, where it was pin 13 is the built-in pin on our Arduino Uno. So 13 was an output, 13 high, 13 low. This was a little strange to see that they were writing to the number 13 high. That seems odd. Writing 13 low, that's weird. Makes a little bit more sense to be more readable if you say, okay, my LED is number 13, is pin number 13, and I want to make the LED an output. That's more reasonable. Set the LED high, high's a little mysterious, low is a little mysterious, but at least I get that you're telling the LED to do something in these cases. So it's slightly more readable. And then I think the most readable in this case, and you could probably argue, is that the LED is pin 13, and I define this variable called glowing and assigned it the value high, because when it's glowing, you'd have it be high on the Arduino. So I set the LED as an output, and then digital write the LED glowing, right? So this is the same thing as 13 and high. It's just through some variables. And then this one, LED and an exclamation point, if you know what that operator means, you know that it means not. And so this is like saying LED not glowing, right? So you're doing some negating, which is a little weird, but it makes it very readable if you already know what the exclamation point means, and maybe that's a big if. But this can keep your code very readable because you're almost directly saying what you're up to. And really that comes to creative use of your variable names and how your program fits together. Like in this case, two variables that are globals that feel a little disconnected, but they get down here, once you're into the meat of the code, they start to become really well applied things. So you have this ability to add readability into the programs that you're writing, even without changing the function at all. Readability and style is definitely an important thing. There's this comic that's pretty common for a developer to late one night, you're up, you're reading books, you're doing the fanciest code things you've ever seen, and I'm going to remember this. I don't need to write any codes in what I'm doing, just typing away and making it happen. And then it sort of works, or you fall asleep anyways, and you're happy with it. And then 2 weeks later, or a month later, or a few months later, you go back and you look at your code, and it's very hard to make sense of what you did. Adding notes can be really helpful. Adding comments to your code is something that I really like to do. In this particular language, I've got paragraph length quote or paragraph length notes that are right along here. I like to put in these big dividers whenever I've got something in there. I will comment things out or put a bunch of comments on what's going on so that I can say like if button state and not last button state, only on key down. So this is like notes to me so that I know what's up in my code and I can keep track of it. And maybe even more like here's another big divider, tells me something big is happening that's different down here. So there's lots of different ways that you can comment your code so that it's reasonable or that you can make sense of it. And those strategies are going to grow with you as you get better and better at coding. So it's definitely something that's a little tricky to pick up at first, but it can be helpful. Once you feel like you want to know how to write code the way that people should, which is anything that works, by the way, at the beginning. And then after a while, if you want to get a job or you want to work on a team, getting your code to be written in a way that makes sense. That's going to be all based around, let's see, it's going to be all based around the style guide. And so the style guide here is something that you can get to in Arduino, and they have a whole write-up of like how you should write your code and what are sort of the best practices for what's going on. So there's tons of different ways that you can do that, where you can get these things to play in, and you can do all sorts of stuff. So they give you advice on how you should structure it, what it should look like, explain the code at the start, the little paragraph length text at the top. Oh, I got a question from Lisa. How do you find the upside down exclamation point on the keyboard? That's a good point. Maybe we're talking about this. This is a regular exclamation point. That one is just the, shift 1 is where that one lives. And so that's what you're doing. Upside down is, it does mean not. So it feels like it's inverting, but it's not the upside down exclamation point. It's the regular exclamation point. Other things that you can do in your code to try and make it make sense is use Camelcase. And so that's what this is, or we can go to the Wikipedia page for it. Camelcase is this style of writing text so that you structure it in such a way that the first word is lowercase and then every word that comes after has got a capital letter. I think I've got an example pulled up in here. If we go down to the bottom, these functions are definitely Camelcase. Let's see. And so this is a structure that's really useful. All motors stop. This right here, that is Camelcase, where the first word is lowercase and then motors and stop are real important words that come later. Here's num motors, all motors stop alt. There's a few different things that you're up to doing. And so for that, there's a handful of ways that you can get your code to work the way that you want. But Camelcase can be really helpful. And then a lot of the time, there's 2 nested layers. So this is a common thing that many developers will try and get you to stick to. Although for a beginner, it's not the most important thing. A lot of people say like no more than 2 nested layers of depth. So if you're trying to conform to standards, to get everything up and running the way that you want, getting yourself limited to just 2 layers of if logic can be really helpful. And then like you probably need to write some other functions or some other things in order to keep that true. I've definitely had things that want to grow much deeper than that. And so you'll be able to find your way in if you just be careful and make sure that that happens in a thoughtful way. But as long as you're clear and your spacing works, you'll be all good. There's a famous quote among developers: always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. It's a little dark, but it's a really famous quote from in the developer world. And this is primarily a joke because most of the time it might be you or future you that's maintaining your code. And so really, you just want to make sure that your life is going to be easier in the future. There's some, I used to have a roommate who was a developer, and he said that readability and maintainability is one of the most important things when you're doing this at a business, because you want to make sure that whoever comes after you, or if you get a new job, you get plopped in and the code that you're reading and editing is unreadable, you've got a huge problem on your hands. And so there's lots of style choices that people will have many meetings about, of how do you want to write the code, not like how do you make it happen, but instead they're talking about what do you want it to look like. And so those sorts of details can be really important if you're going through it. But then there's a lot of room of thought on this. So there's entire books dedicated to this confounding problem within code. So there's lots to think about here. I would say another thing, in addition to readability, maintainability is super helpful. This is how you do things that can help isolate problems and minimize repeated processes. The old adage is that a coder is lazy, and that is not to say that they don't work hard, or that they, what they want to do is write code the least amount of time as possible, so that they isolate where variables get changed or where logic happens, so they can keep repeated things all contained into little boxes. And so maintainable code that's clear should have comments in it. You should write separate functions for repeated processes. That's more maintainable. To do something repeatedly from a function is a lot better. Isolate logical steps if you can. If you've got different functions that you're working on, that can be really helpful. and build functions and properties into objects whenever you can. And so there's some examples of that. Thinking about objects can be really helpful. We're going to talk about object-oriented programming in just a second. But these are the sorts of skills that it takes years to master. Even a professional developer is going to be arguing with colleagues about what's readable and what's maintainable code. And so there's lots of choices like that you'll have to do. Some companies even standardize a file so that it manages how they style their code specifically. You can do that inside of VS Code. There's some really important details to getting those two pieces right. But we're talking about lifetime achievement awards here. But what is much more approachable, even though it's a little bit esoteric, is object-oriented code. And so this is a hallmark of any of the higher order languages. It's how all Arduino libraries are written. And I really want to point out that Adafruit does a fantastic job of teaching this. Here's their website. It's a classy solution. And I just search this, put a little oop in your loop every single time I want to find this, because I love that line. And it puts a little object-oriented programming into your code. And so that makes your life a lot better. And they go through and explain how and why that is. So you can read through this tutorial, make some sense of it, and it'll take some time. Don't get me wrong. If everything we've been doing now is learning how to add and subtract, this is learning how to multiply and divide. So this has got its own complexity. But once you figure it out, it becomes just as nice as like parametric design within 3D modeling. It's the sort of thing that you really start to not want to walk away from once you get the power of how this can be used. And so really object-oriented programming works nicely when you've got lots of repeated things, especially if they're physical objects that you're talking about. And so typically these are called classes, is the key word for an object. And then they have methods or things that they can do. And usually if you have a class or a method, it'll make implementation easier. Like in this weird Arduino project, that doesn't seem to make a lot of sense. Here's 1, 2, 3, 4, 5, 6 LEDs and 4 potentiometers. I don't know what they're up to. But if you wanted the behavior to be the same for all 6 LEDs, like you wanted them to blink and maybe your knobs are changing the blinking speed, but fundamentally they're really similar. If you write one object, you can just repeat it 6 times so that it gets used, sort of like a function, but for a more complicated thing than a function. Some property, right? Like you'll need to store that this LED is on pin 4, and this one's on pin 5, 6, 7, 8, and 9. You're going to need to know that information about them. Then you'll want to have actions for them to do. There's a lot of details that go into this, but it can be a really powerful part of how you can control things, especially in Arduino projects where you might have 6 motors and a button, which is exactly the project I'm working on. 6 motors, 6 LEDs, and a button. And so I want to manage the LEDs and the motors really repeatably so that they're consistent in how they behave. A good example is this right here, and I'm going to pull up on Tinkercad this particular project. So I'm going to copy this and tinker with it. Inside of here, this is a traffic light, like a simple LED traffic light of red, yellow, green. And it's a relatively simple project. Here's the code written in the sort of procedural format where I go in and I write. It's not very maintainable. It's not super readable. This is the like, just get it done, click, 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 make sure that in 20 lines of code, it's over, right? And there's some value in that for sure. But in here, I decide that pins 9, 10, and 11, where these are connected, those are all my outputs. And then I write them high, low, and wait, high, low, or low, high, and wait, low, high, and wait, low, high, and wait. And then it loops back through. This is sort of the quick and makes it happen fast process, the way that you can get it to work. And this is object-oriented code. And for this simple example, it definitely adds more lines than it takes away. I get that. But when you get to bigger, more complicated projects, the reverse is going to be true. One well-written object can save you lots and lots of code later. So for this, an object is written up here, and this is basically everything I want an LED to do. It's an LED, and here I define the LED, get it set up as an output, and then I have a flash method, so a method that just blinks the LED on and off. And so all of this is described in what an LED is. This is what an LED is and what an LED does. And so then down here in my program, I can say I'd like these LEDs to be created to match that specification. I want them to be instantiated. And then down here, I want the red LED to flash. I want the red LED to take the object flash or the method flash. the yellow to flash and the green to flash. This can be pretty readable code down here at the bottom, and it leads to the same output. Let's see, I'm headed into, oh, is this? And pop out of here. Here's my example. So if I go to my code and look at this in Tinkercad, here's the procedural one. If I just start the simulation, what this is going to do is that it blinks these LEDs, and it does it every 500 milliseconds. It blinks the next one, right? So as you do that, it's going through and it's blinking. There's nothing earth-shattering about it. It's just got the three where we're controlling them. But if I do the object-oriented code, and we can pop in over here and look at it, we'll open this and tinker with it. It's got much the same thing. It'll be the same circuit that's there. It'll be, and so here's the same exact circuit. And I open up the code, and you can see it's a lot longer. But up here, everything up until this point is all the object. And so that's where I stop defining my object as above this line. And in here, I'm saying I've got an LED. This is where it's described for what it is. I say, here's its pin, the pin that it's attached to, the timer for however long I want it to blink for, and make its LED pin an output. And then flash is the action. And for that action, I just want it to turn on the LED, wait 500 milliseconds, and then turn off. And so down here, I say, okay, the red one is going to be on pin 9, and I really want its blink to be 500. And this is all done and set up way before and outside of the void setup. So this is, the void setup is the thing that happens first in your code, but the void setup is really the first thing that your Arduino runs. But this compiler all happens outside of it. It's a little wonky that it happens outside of setup, but this is in objects, you usually set them up outside of a function. And so here I've got these three LEDs all set up on pins 9, 10, and 11. I put in their timers, and if we hit start simulation, you'll see that it runs exactly the same as the other ones. And so there's the blink, blink, blink. There's no different. But what happens is inside the loop, instead of, what I really want you to look at is the loop, right? The object is a little tricky at the start, but if we go look at this loop is really long, right? It's long, there's lots of things. It's digital write is in there. It doesn't say anything about really what's happening, about flashing one LED or the other. But if we come back over to this one and look at its void loop, it's 3 lines, it's nice and short, and it's saying red flash, yellow flash, green flash, and that's pretty directly describing what's happening. And if I wanted to, I could even change, like, instead of being 500, let's make it 1500. We can see that these are going to behave in the way that we described. It's the yellow one's a lot longer. It's 3 times longer than the other two, but I'm able to take this prototype of an LED and add in the behavior that I want, describing each one separately. So it's a really powerful way to take your description of how these things work and add in repeatability and a pattern, right? I'm able to describe the LEDs and do all of this business right down here in much less code. This is 17 to 27 almost, basically, for my program, if you ignore the object part. And so that's a lot less than these, it's a little less than these lines of code. So I'm able to condense the code, make it more readable. Objects can be really helpful anytime you've got lots of repeated things. But there's totally some patterns to it, some details that you've got to figure out to make it work. But I would say that in the long run, there's a payoff to it. Like, for example, the project that I'm playing with, here's a button object that I described. And so this is class of button, and I'm working on a thing with a button. It's really helpful to have this constructor. And this is what I would do in the void setup for that button in a constructor. And then here's to check the button. And so this is going to do all of the stuff that it takes to check a button. And then when I go into my main section of the code, all I need to do is say button.check, which is kind of like saying check the button, and it returns either true or false. And so it's nice that that code lives in one place for how to do it. And now I'm just able to say, okay, I would like you to check the button, please. It isolates things out so that you're not thinking about it all in the same place. It doesn't turn into a big spaghetti mess. So object-oriented code is tricky. It's good for us to look through the details and try and make sense of what that is. What's the structure of how that works? And so we're going to take a look at it here. We're going to really double down into how do you define them right now, but it's also worth it to look at down here. There's the instantiation of an object happens before the void setup, usually by tradition. Then the void setup often doesn't need to have much in it. And then your void loop is where you run the methods, where you do the things that you describe up in the object. In general, this is more maintainable. It gets things to work more nicely. And it's how a lot of the web is written. So JavaScript is an object-oriented language. And so you can write lots and lots of objects in JavaScript to make sense of the world. Here's specifically this like flasher LED. So this is just talking about one way that you could describe an LED. A flasher is going to have one variable in it. It's going to have the pin that the LED is on, and that's it. So if I have a flasher object to describe an LED, I'll need to know what pin it's on, like if it's on pin 9, 10, or 11. And then here's a constructor. A constructor is something that's public. It needs to be accessible. Private, this is a private variable up here, the LED pin. You can't get to it easily from outside of the object. The public things you can call within your program. And a flasher is how you make a new flasher object. So the constructor, all I need to do is call this and put in the pin. And then it's going to remember that in my private variable. That's what it's doing in this line. And then it's going to make the LED pin an output. So it's just going to assign it like the void setup part. The constructor is definitely the setup of your object. And then these are your two methods, the two things that your object can do. It can turn on or it can turn off. And these aren't very elaborate methods. Don't get me wrong. Turn on is just LED pin high. Turn off is LED pin low. But I like these particular methods because they make it more readable for my object. Makes it a little bit more clear what's going on. And if you come back over to here, and I wish that I could zoom in, but on the slide, you really can't too much. Well, we can do this. In here, if I'm looking at this is where I instantiate my object. And so the flasher, I call it LED1. I say I want a flasher object, and its name is going to be LED1, and it's going to be on pin 12. A flasher called LED2, going to be on pin 13. And so I have these two things, and their names are LED1 and LED2. Not very creative. Maybe they should have been Fred and Sally, but some sort of a name is assigned to them. And so LED1 I turn on, LED2 I turn on, I wait for 1,000 milliseconds, and then LED1 turn off, LED2 turn off, wait for another 1,000 milliseconds. This is not the most complicated sketch in the world, but it gives you a chance to see how do you use an object to make something with a name, pass in its parameters in a constructor, and then how do you use the methods? A lot of JavaScript will just have method, method, method if you're looking at how the web is built. And this dot function name with parentheses for parameters, that is really common for the formatting there. So we'll head back over to this. Those objects are really worth learning if you wanted to get higher level skills in your coding journey. But the last bit, and this is really the sweet relief of this, the sweet value, are libraries. Arduino calls them libraries. Other parts of the world sometimes call them APIs, but a library is code that somebody else wrote, that you don't need to write, that makes it super useful to do other things. And so libraries can be all the better. They really help you when you buy something that's relatively complicated. Like if you realize you're working with an Arduino and you need a motor shield to drive some motors or things, then you can use an Arduino library most of the time to control that shield. And so this is a motor shield, an Adafruit motor shield, it looks like. And so this motor shield would come with a library from Adafruit that you can download and you can just use right in your code. And if that's the case, they've already got all the pins mapped, they've already got all the stuff done. All you would need to say is you need to find the methods that they have for you, make the object that you need to make, and then usually you'll say motor 1 drive forward. And it's that easy that you'll be able to do it. They really can, because it can be a lot of code that someone else wrote, you can save yourself tons of energy and time by using a library so you don't have to figure out all the different things. Libraries themselves are always written in an object-oriented format. So that's why object-oriented programming is important to learn before. And there's a library manager that you can use. Also, there's this reference for libraries. So there's all sorts of them. Here's the categories of them: communication, data processing, data storage, device control, display, other sensors. There's 900 just for sensors alone. And so these are all libraries that someone else has written that you can just download yourself and you don't have to write anything. Like here's things from the Adafruit shop, things from the Trinket Gemma. Adafruit writes tons and tons of these. so that their customers can get whatever they need and it's not hard to use. There's all sorts of different ways that you can do stuff with this so that you can use other people's code in your projects. The library manager inside of Arduino is really nice. You go into its sketch, include library, manage libraries, and then inside of here, it pops up with a thing. And so a common one that I'll usually want to get is encoder. And I really like the one by Paul Staffordgen, I think is his name, and I'm gonna search around until I find it. But encoder, there's a few different, these are all people that have written encoder libraries that are just there so that you can use their code directly. And so this is the one that I really like. Paul Staffordgen, I think is how you say his name. He's written tons and tons and tons of, and I think I have the most up-to-date one installed. He's written tons of these libraries. He works really closely with the Arduino development team. And so if you ever find one from him, it's a gem. This lets you use an encoder, which is the thing that we all used on the Arduino Learning Shield. And so this is really, really helpful for using those sorts of things. But there's a bunch of these, and they make it much, much easier to use. Almost always, if we go to File, Examples, and then down here, for any of them that you've installed, you usually get examples down here. So here's encoder and the basic example. Here's some example code of how to use an encoder. It's pre-written. You can just read through it, see what they did, and use the same functions. But here's like the my encoder object and then read. There's the object-oriented part of it. Here's the constructor that instantiates it, where I use the encoder class and call it my encoder and say that it's on pins 5 and 6. So this is the structure of using a library. They're super useful because it's all right there. And there's lots of things you can get as a free benefit. As a side note, Serial is a library that's just baked into Arduino that we've been using all along. So Serial is itself a library. It's just one that's included by default. So you don't have to do this thing where you include it as a header file that's attached. So Serial you get for free. There's a few others that you get for free inside of Arduino, but this one is really, really helpful. So that's definitely a good one to check out. Or Arduino libraries in general can be really helpful when you're trying to build complicated things. So Serial was a secret library all along. It's been a library. You don't need to instantiate it. It does that at the beginning for you. This is just asking it to do its begin method to open serial communication. And you input parameters, right? If you serial print, that sends out hello. Print line sends the whatever's in the quotes, and then it also sends a carriage return or a new line character at the end. So this is a simple way to get communication going back and forth. And that's because someone wrote all of the code that it takes to get your Arduino to talk to the computer, which is a huge upgrade because that would be really hard to figure out on your own. And it's really helpful that somebody else did it. So that is a lot. We've gone through lots of big ideas here, headed all the way back to the beginning. We talked about functions in code, variable scope, readability, maintainability, object-oriented programming, and Arduino libraries, which is a lot of concepts. And as we think about that, the key thing is what's next? Like what is the thing that you should do? And ultimately, you should start building stuff with Arduino. So this week, you might want to spend, if you liked the guided tour through those lessons, you're welcome to keep going with those. If you want to work on things in person, absolutely we can. A really nice way to get this up and running is to try and add in LEDs, which can be done on a breadboard. We gave, everybody's got an Arduino kit from earlier on in the course. You could dig that thing out and start playing around with the LEDs and try and hook them up. These are the 6 totally viable ways to attach an LED to an Arduino, by the way. There's the power indicators like these. These are sort of the normal ways. These are the inverted logic ways to use LEDs. There's tons of ways to use them, and then even more ways to control them with your code. But this is going to be, getting some application can be the best way to get started with Arduino. And so just playing around, just getting things to blink that's totally at your control is a really empowering way to better understand this stuff. So that's certainly the next thing that you should go for. If you're stuck troubleshooting, we were chatting about this at the beginning, but in your code like this, if I hit the check mark, the Arduino IDE is going to check all of my code. And so here I've got a little code folding I'll undo. There's all of my code for this. And you can see it ran through. All of my text is white, which is great. It means that nothing was broken. But if I miss anything, troubleshooting is a big part of the Arduino process. And so you can see here, it threw an error, right? It gave me some red text, some red things, expected a semicolon before delay. And it doesn't exactly nail it ever, pretty much. But it's giving me a hint that around here, something went wrong. And so semicolons, it's pretty good at spotting. It's definitely worse at finding missing brackets. It's there, it did a good job. But sometimes it's a little bit dicey at how it finds the missing brackets. And so you want to be careful about that, but go after it. Let this help you in troubleshooting. There's lots of ways to get better at that. Library not found is a common problem. That's something that's going to be really helpful if you're trying to use the encoder library, but you didn't include this or you've accidentally commented it out. It will throw an error as well, saying that I don't know what an encoder is. It does not name a type. You just need to make sure that you're including the library that you intend to use, and then it won't throw a problem. And so those are really common things that can happen. Maybe you forgot to identify the COM or USB port, which happens up here in Tools and Port. So up there, I'm got an Arduino attached to COM4. You can also have variable scope issues. We covered it this week. That line needs amended. The serial baud rate doesn't match. This is a thing that you might get if you're jumping from one IDE to the next, forgetting to plug in the Arduino or power. Those sorts of things can be really important to think about. One thing that's also really interesting when you get to more complicated projects is you can also draw so much power from your Arduino that you half brain it, where it sort of kind of works and it sort of kind of doesn't. And those are the worst problems. If you get into a point where you think you might be half braining your Arduino because it's using a lot of power for a big motor or something, then you should definitely try and figure out what's going on. So next steps, pick through the example sketches in the Arduino IDE, play around with those lessons that are still in the Foundations chat. I'll post them again after class just so that we're good there. Try hooking up LEDs on your desk. It'd be lots of fun to see photos of people with LEDs this week. And try and write some code, play around, do the things. If you get to a frustration point, this is good news. This is not a job interview, so you do not need to go all the way to the end. But if you want to and you're interested and you want to make it happen, you can totally do it. I'm going to be around on Thursday and Sunday again, just so if you want to play around with these things, we can totally make that happen. Also, if you want to play around with the project that I was coding and that I flipped it back and forth to a few different times, and this is by no means perfect or done. I'm trying to figure out how to write the code to water the plants and to do that effectively. So if you wanted to read through this code that I posted and been messing with, you're absolutely welcome to play around and to see how this works and to help me actually get the plants watering if you'd rather just do something that's applied. I'll be around. That's what I'll be working on if nobody wants to do anything else specific on Thursday and Sunday, is working on getting these plants up and running. Because that ought to be fun and it's useful. That way the whole MakeHaven system runs a little bit better. So those are the things to cover this week. That brings us to the end of our coding discussion. These are 2 weeks of coding, which is a lot. By the way, I don't want you to think that this is I think that this is a cakewalk topic. This is definitely a head scratcher. It's a complicated concept, and there's plenty of reason to feel a little frustrated, and that's okay. The coding is definitely a frustrating sport, but the better you get at it, the more rewarding it can become. And then eventually it starts to become a superpower that lets you build things that can interact with their world, which is really like kind of a mind-blowing level of skill when you get there, that you can build something that can sense the environment around it and respond to those things. We're going to circle back to the applications of code in a couple of weeks. We'll talk about inputs and outputs, but for right now, it's just good to be able to build these skills so that the code pieces can be at least understood at a level without any of the inputs and outputs. So that's the big thing. I'm going to stop my share and head back to taking a look at everybody. We've got it's 8 o'clock. We need to do our show and tell, to just chat about what we've been up to this week. And it could be that we were all coding, or maybe we're doing shoveling the snow from our nor'easter, or who knows what happened this week. But it would be lots of fun to hear from all of you what you've been up to and what it is that you're planning on going after this week. So let's see. Everybody is dark right now. Whoever would like to James, there you are. I see your camera.
Yeah,
what have you been up to this week?
Basically this week I've just been working through the 5 examples that you had on Google. And I had a lot of fun with it. I had some challenges, but it's interesting to kind of like track down like what I'm doing wrong or what I'm looking for, and to like read through the documentation on the Arduino site, which is like ample. Like I pretty much have had every question answered by somebody who wrote it down somewhere for me, essentially, right? Like yeah, I had a lot of fun just like messing around and confusing myself.
That's great. Yeah, I think you get at a key point, is that this can be really frustrating and hard, but like in a lot of the same ways to math, but it's not really math all the time, but it's something that someone invented, right? So it's something that is then figure outable.
Right.
And so it's fun to figure it out.
Yeah, so actually like a really silly thing that like drove me crazy was that I was trying to do if else, right? Like make like an if else thing. And after else, just because I had written it every time I wrote if, after else I put parentheses down, which doesn't work because you don't need parentheses because there's no condition to else. And that I was like, I'm gonna scream. And then I looked at it, it's like, all right, like you don't need that. Like stupid mistake, but something that I'll never ever forget again.
And that is totally how it works. You just like make a million little mistakes and they all accumulate, and then one day you're an expert.
Well, I don't know about that, but, but yeah, it was definitely fun. It was definitely like a fun thing to look at. So
cool. Yeah.
Cool. That's it. I got to shovel. I got to take a nice walk in the snow, which was fun, and that was it.
Yeah, that's great. Lovely. Cool. Nice week. Cool. All right. Let's see. Anybody else want to unmute your camera or self and tell us what you've been up to? We've got Norm is on camera and unmuted. So Norm made it first.
But on the other hand, I've got nothing to say except that I did the same stuff that James did. But I topped him because I added the project of finding my Arduino and plugging it in, which led me to a question. I plugged it in, and lo and behold, it blinked. So I guess I downloaded that program. But then I said, well, let's see how that is working, how it was written. And then there doesn't seem to be any way. I couldn't find a way of locating what was written on it. I could reload it and see if it does the same thing.
That is, you're totally right, Norm. That is the classic problem with an Arduino, is that I would always love to get the code that I've written back from it, but it is definitely a one-way street.
Okay, well, at least I'm not missing something obvious.
Yeah,
but that's what I did. The only other thing I did is I have it on my calendar this time of year that I'm supposed to clean the ceilings and walls and retouch them up. So I've been doing that for the last couple of days, and I would never do it except I put it on my calendar, so I know I have to do it, and I can't evade it that way because it's on my to-do list automatically.
I aspire to that level of precision. That's very commendable, Norm. Very nice. All right. Let's see. Lisa, how about you? What have you been up to this week?
Can you hear me now?
Yep.
Okay. So I was slowly just trying to work through, I actually printed it out because, as you know, I went away this weekend, and I figured, well, rather than, I actually lugged the laptop, but it would be easier just to use this than turn that on. So, but I was having too much fun in the snow to use it while I was in Vermont. But last week I did slowly work my way through, and it's, for me, it's just every little detail has to sink in. So it's very slow going. And as a result, it's not like I even tried to write any code. I'm just trying to read through the thing to get to a point where I then can start trying those exercises. It did help me refresh my memory in some of the things that I already did, you know, those many weeks ago. But now I wonder, when I go back at it tomorrow, am I going to remember what I read already? So, you know, I'll see how it goes, but it's definitely hard work to sink in.
Yeah, it totally is. There's no universe where it's a cakewalk. It's taken me years to get to where I am with it, and it would take, I think it would take anybody years.
Yeah.
It's just complicated.
Yeah. And so, I mean, Corey knows we worked on my carving board a little bit more, and I think we got some success. So now the next time, whenever I set aside the time, I can go in and take the real board and cut it, and I could show you guys what it looks like, what we did, if I could succeed in sharing my screen. So I'm going to try again. I'm going to hit the share screen button, and up comes this little screen here where I say, shh. Oh, okay, there we go. Share. Well,
All
that's
right, looks like it's trying. It's on its way. There we go.
okay. So that's just one shot of, this is what happened. I didn't like, and I guess Corey didn't really love the results of the first time we tried to cut this mock-up pine board of what the cutting board would be. The tool just didn't make a nice shaped path. And so I did a little research online and came up with some bits, some end mills that would work better, called Cove bits, I think. And so here we are. Corey helped me assign the paths, and we did it, but by mistake. The inner one is what cut, and it was a smaller proportion to what the board should be. So I said, well, let's just cut what it should have been around the outside. And so that's the size it should be. And we scaled up all the files. So hopefully when I go and do it on the real board, it'll cut right. So it was kind of exciting, at least to see what it looks like, what it could look like. And let's see, do I have the ability to share with you yet? Okay, so that was it. That's what the board that looks like that we're going to cut into, and I want to sand it down some so you don't see those old stains on there. But it's a really huge, thick, heavy, beautiful board. And I'm trying to make my way to, wait a minute, other direction, so you could see the beautiful Vermont snow I was in. Oop, that's the dog that was with us. There we go. So that I had that whole thing to myself there. There I am. That was the nice dinner I made. And this was this morning. And by the way, it was 5 degrees.
Whew.
So that's it.
Are those cross-country ski tracks?
Yes.
Nice.
Yes. That's what I do. There was nobody there. It was a golf course, but it was tracked for skiing on. So
I remember when you used to have to pick your wax and it had to be exactly right or it wouldn't work.
That's right. That's how I started. Started with waxable skis with tar bottoms all the way till now. So it was lots of fun, even though it was absolutely freezing. So
I have a Shapeoko question, and it must be idiosyncratic to me. I once used a 1/4-inch bit and there was no problem putting it into the collet. The last time I tried it, I felt like I had to force it too much, and I just ended up using a smaller bit, which didn't cut right, of course. Is there something odd about the collets that they accept some 1/4-inch ones and not others?
No, that's a really good question. And the 1/4-inch collet that's in there now probably could stand to be replaced, is the short answer. somebody clamped it down in a weird way that applied a little bit too much pressure when there shouldn't have been. And
Oh,
so
okay.
it bent in the legs just a hair enough that it's hard to get it on.
Yeah, I couldn't
I'll-
use it. I just put it aside.
Yeah. I used it with Lisa, and by the time we were done changing bits, and we had like 5 or 6 bit changes,
Mhm.
it was relatively easy to get them switched in and out. What did you say,
Wow.
Lisa?
Yeah, yeah. I was able to do it by hand, which was unusual. I didn't have to pound it out with another tool.
All right, I'll be more aggressive next time.
Yeah, we were aggressive originally.
And then it turned out to, after a few in and outs and a few uses, it turned out to be okay. So
Yeah.
Thanks.
So you can unshare me now if that's how it goes.
yeah, I can do, there we go. I got it.
Okay, good.
All right. And then Arvia, if you're still around,
Yes, I'm here.
you were doing some
Um,
cool stuff this week.
yeah, I was sitting here and just was not preparing. Yeah, I didn't get a chance to do last week's lesson. But during the snowstorm, I basically watched Netflix all day on Saturday and hung some curtains
great.
up, which is like literally the bane of my existence. I hate hanging curtains. But I also on Sunday I started my accent wall. Sorry, I'm stuttering because I'm trying to get my screen together too. But I wanted to do I can just show y'all. Why am I about to share my screen? Okay. Doing the most here, y'all. Here I am. So I started the accent wall in my bedroom, and I finished it today on my lunch break. It's kind of dark in my room, but let me show y'all it. How do I flip my camera? Okay. So this is my accent wall. There's my door.
Oh, nice.
So I painted the like mural and cut down some wood pieces to make these little slat sides. Yeah, I'm really excited about it and feel really good about it. So yeah, that is what I did this weekend pretty much.
That is such a good use of a weekend.
Yes. I'm very happy about it. I don't know how long I'm staying at this place. My landlord is probably going to be very pissed off, but I know I used the nail gun to put the slats down. So those will pull right out the wall and I'll just paint it back. So yeah, I figure I work from work from home. I'm like, I need my place to feel like me. So
yeah.
yeah.
That's definitely, when you're going to live there for a long enough time, it's totally worth it to make something your own.
Yeah,
That's awesome.
absolutely. Thank you. I definitely need support in this coding part. I might just come in on Thursday and try to get like an in-person lesson because my brain is not computing the things. So yeah.
Yeah.
Excited to try to learn it.
That's great. Happy to on Thursday. That's lots of fun. I was also thinking while we were all chatting, and I'm gonna actually share my screen again. I was thinking about the microbit. And this is something that you can do also. So it's got a target age of really low, but sort of like Lego, that target age has a big range. And so if you get one of these, they're like an Arduino, but all the things are connected already. And I've got one in my bag, which is right behind me, that I borrowed from JR and should have given back a long time ago. Sorry if you ever watched these, JR. So somewhere in my bag here, I've got one. And they are this little circuit board, and there's a ton of stuff on them. And you just plug them into your computer, and basically they work. So if you go to Let's Code, there's a few different ways that you can do this. You can write your code in Python. You can manage classrooms of this. So this is intended originally for teachers in England to teach code. But if you just go to the MakeCode editor, there's a ton of examples, but you can start a new project, and with a little bit of help, you can say on start and forever. So this is void setup and void loop. You can say on setup let's do an LED plot 0, 0, and there's that point. And maybe we don't want to do 0, 0. Maybe we'll want to do 2, 2, 0. And you can see live, it's simulating out what this is going to be. And so you can, if you want to, there's ways to make code work like this. Tinkercad has a very similar thing for Arduino. The reason why this is not my favoriteest platform is because it doesn't integrate as well as Arduino. With Arduino, you can attach it to whatever. For the microbit, which is a lot of fun, it's a little bit dicier to get it to connect to whatever, because you've got these different pins that aren't sort of a standard shape. But it's really nice, approachable code. If the code that we're doing is really not your jam, I would always recommend for anybody to hop into Tinkercad, and then you can just grab an Arduino like this and then code and leave it in block mode. This is got no void setup at all. It does all the setup for you. You're just doing what's in the loop. And so you can do this and it'll run this code to blink that LED without any other setup. And it's got lots of different complicated options, like you can do math, you can do whatever. If some people really hate the punctuation part of code, this is a great way to get it up and running. So if you're finding that, and it's got its own funny business, like where is it hidden? Is it a notation thing? Is it variables? Is it inputs or outputs? Those are all like, they've got their own complicatedness. But if you want to play, like we were talking, and the if then else, right? This is where if 1 is less than 2, this is not really a great if then else thing, but you can imagine sort of the logic that you might want to build out this way, where you can start to have these snap together. You can build in controls and whatever you want to do. There's tons of different things that you can make happen. There's different ways to get access to this code and programmatic solutions. If the coding part feels unpalatable, but you can do this, and then it just sort of writes in the code for you if you wanted to do that converting. So you can download this directly to an Arduino if you want, and upload it from there. There's tons of ways to do all of this. I'd love to support anybody on Thursday and Sunday. And the one big announcement that I'm going to be annoying on Slack, trying to get a hold of everyone's attention, is that we are trying to, and here I'm sort of working out the details. I'm going to put my Slack on screen while I'm still sharing, working on trying with Nora, who's I think she's a PhD candidate at Yale, about biology things, and a few other teachers in that space, about next week, which is Community Biolab. And so we're going to get together and talk about biology and how all of that can happen here in MakeHaven, how you can do interesting biolab stuff in the space that we have together. There's tons of cool opportunities that you can do. What we'll be doing is a PCR test and a gel electrophoresis, which is where you swab the inside of your mouth, and then you get to test and look at your own individual DNA to see sort of what does that look like? How is it made? How do you make copies of it, which is something that you're doing in a PCR test? And then how do you analyze all of that so that so that you can tell if you have one gene or another. So if you wanted to do some genetic testing, I want to say very clearly, we're not doing high end or very specific genetic testing. We're not even getting to get close to 23andMe or any of that stuff, but it's sort of a fun biolab. The biolab can do that, which is very much like a thing you do in college biology, but you can also grow your own leather out of orange rinds or coffee grounds. There's all sorts of weird things that you can do in a biolab that are really, really fun and really, really complicated. So there's cool things that can happen. We're just going to do one of them that sort of fits into its own neat little box that's easily done. We'll start that on Monday next week, and then when we do that together, we'll sort of do phase 1 as a unit, and then we'll have another time later on, maybe that Thursday, where we'll need to come in again and you can see the results for you specifically and how that compares. So there's some really cool stuff to that, but it's definitely everybody comes in and does that experience together. We're going to do that for the biolab this week coming up. And then in another 2 or 3 weeks after that, there'll be another one of those where we do composite materials that way, which is building really complicated materials out of multiple things at the same time, like epoxy impregnated fabrics and stuff that are stronger than steel by weight. So there's some really cool things in the near future that we're going to be doing that aren't code. So if this feels like a lot, we're going to have some good breaks from it in the next little bit. So those are the important news items for the end. And it's going to be lots of fun. Those things are going to be really, really cool. And it's sort of like the dessert for making it through the work of learning the basics of code. So with that, there's tons and tons of fun to be had in the near future. We look forward to seeing all of you next Monday, if not sooner. So that's it, everybody. Stay warm, enjoy the snow while we've got it. And we'll see you later on this week.
Good night, everyone. Bye.
Yeah. Bye. Good night.
Bye.